Hello everyone. Today I am excited to introduce you to a mind boggling concept from the world of quantum mechanics called quantum superposition. Quantum mechanics is a branch of physics that describes the behavior of the smallest particles in the universe, like atoms, subatomic particles, and others. So, these particles don't behave like everyday objects we see around us. And that's where quantum superposition comes in. So, the study of quantum mechanics is not only fascinating, but also holds the potential to revolutionize the way we live and interact with the technology. So, let's dive into the intriguing world and discover how the strange behavior of particles at the quantum level can impact our lives. So, why does quantum superposition matters? So, before we delve into the concept of quantum superposition, let's understand why it's important. Quantum mechanics, and by extension, quantum superposition, has the power to reshape our understanding of the universe, giving us insights into the nature of reality itself. So, moreover, the principles of quantum mechanics have practical applications as well. Quantum superposition plays a crucial role in emerging technologies like quantum computing, which promises to revolutionize industries like healthcare, finance, and artificial intelligence. By understanding quantum superposition, we can grasp how these technologies work and appreciate their potential impact on our future. So, in order to understand quantum superposition, we first need to know a bit about the building blocks of our universe, like, like their particles. So, everything around us, from the air we breathe to the screen you are looking at just right now, is made up of tiny particles, such as atoms and subatomic particles like electrons, protons, and neutrons. These particles are so small that we can see them with the naked eye, and they behave very differently from the objects we interact with every day. So, one of the most fascinating aspects of the quantum mechanics is the concept of the wave particle duality. So, this means that a particles can exhibit properties of both particles and waves. Now, imagine a tiny electron. Sometimes it behaves like a little ball bouncing around, and at other times it acts like a wave, so spreading out and interfering with other waves. So, this dual nature is fundamental aspect of quantum mechanics and sets the stage for understanding quantum superposition. So, particles in the quantum world have a unique property called quantum states. So, these states represent the various possible configuration of a particles, such as its position, energy, and other attributes. In classical physics, particles can only be in one state at a time. However, in the quantum world, particles can exist in multiple states simultaneously. So, this is where the concept of quantum superposition comes into play. So, quantum superposition is the idea that the particles can exist in multiple states at the same time. So, this may sound impossible, but it's fundamental principle in quantum mechanics. So, remember the concept of the wave particle duality we discussed earlier. So, when particles are in their wave like state, they can spread out and exist in multiple possible configurations simultaneously. So, let's use a simple analogy to understand quantum superposition. Now, imagine you have a coin that is spin on a table, So while it's spinning, you can say for a certain whether it's head or tails. So in a way, it's both heads and tails at the same time. So when the coin stops spinning and you look at it, it's either heads or tails. So in the quantum world, particles are like spinning coin. They exist in multiple states until they are measured or observed. So when a quantum particle is measured or observed, its superposition collapses and it assumes one specific state. So this process is called wave function collapse. Essentially, the act of measurement forces the particle to choose one state out of many possible states it could have been in. To further illustrate the concept of the quantum superposition, let's discuss a famous thought experiment called Schrodinger's cat. So imagine a cat inside a closed box with a radioactive atom, a Geiger counter, and a vial of poison. So if the Geiger counter detects radioactivity, the vial breaks, releasing the poison and killing the cat. So in the world of quantum mechanics, the cat is both alive and dead until the box is opened and the cat is observed. So this thought experiment highlights the bizarre nature of the quantum superposition and how it can be difficult to wrap our heads around. Although the concept of the quantum superposition might seem abstract and far removed from our daily lives, it has some very real and exciting applications. And let's explore how this strange phenomenon is being used to develop groundbreaking technology. So one of the applications is quantum computing. So one of the most promising applications of the quantum superposition is in the field of quantum computing. Quantum computer use qubits instead of the classical bits we find in our everyday computers. So while classical bits can be either 0 or 1, qubits can exist in a superposition of both 0 and 1 at the same time thanks to the quantum superposition. So this allows quantum computers to perform multiple calculations simultaneously, making them much more powerful than classical computers for certain types of problems. Let's see this animation if working. Okay, I think it will take time. Okay, let's leave it and I will attach the link to this tutorial. I think we stop. Okay, so this is the complete let's play once again. So this is the animation of a qubit spinning. Okay, so let's back to our presentation. So with the power of quantum superposition, quantum computers can tackle complex problems that are currently too difficult for or time consuming for classical computers to handle. So they can process large amounts of data and solve optimization problems. So the algorithms which I mentioned here can be used for the optimization problems. Quantum superposition has the potential to impact several other areas as well. For example, it could lead to the development of new cryptographic methods that are virtually unbreakable, ensuring secure communications. So I think I should wind up now. Thank you.